All right, friends, we are live on YouTube, and we thank God for this chance to have Sir Benson again taking us through week 2. So, Papa, you're most welcome. We are already 6 minutes into the time. Thank you.
Thank you so much. We thank God for the privilege of meeting again, and I hope everyone is fine and doing very great. Before I continue with this lesson, I just want to trust that those who are available now have been able to go through the slides that I shared yesterday. So what I want to say is that in case you've gone through and you're having any challenges, you can contact me privately and we can have one-on-one so that we could clarify whatever is not so clear to you. With that said and done, today we shall be looking at sets and operations of sets as our scheme of work stipulated. And talking about sets, please, I hope everyone is hearing me loud and clear.
Yes, please.
Thank you, sir. Talking about sets, set is basically a collection of a well-defined objects. So when we have a group of objects that we well define them, then we classify that as sets. For example, if I say that the set I'm talking about is, say, the Ekropon Presbyterian Church of Ghana, and the members of the church then becomes my set. If I say a set of tables in a class, say class A, then that becomes my set. So any set of a group of objects or collection of objects that is well defined, that we can determine who is a member and who is not a member, is termed as a set. Good. And the elements or the members that make up a set are called the elements or members. So the objects that make up a set. So for example, if I'm talking about the set of objects in a class, then so long as I've defined, let's say, a class in, say, Presbyterian school, then so long as I've defined that set, then I know specifically when I enter the class, the members I expect to see will be, let's say, the things in the class will be tables, chairs, and what have you. So when we define a set, then the objects that make up the set are called the members or the elements of the set. And we usually represent a set by capital letters such as A, B, or C. So for example, if I am defining, say, a set of boys and girls in a class, then I'll use the capital letter B, for example, for the boys, and the capital letter G for the girls. So when we are describing a set, we use capital letters to represent the major or the main sets. Then the elements or the members of the sets are put in brackets or braces, which are separated by commas. So for example, if I define my set to be the colors of the rainbow, then I'll use a variable to represent the rainbow, let's say R. Then the colors of the rainbow, which will be the members, that the red, gold, green, and what have you, will be put now in curly brackets or braces, and they must be separated by commas. So a set may be defined by listing its members or describing them. So if I want to define a set, what I will do is either I list the members or I describe them. So for example, if my set that I'm describing is the set A of even numbers, then I could list them as A equals to, I open bracket, even numbers, or A equals to 2, 4, 6, 8. So either I am doing a listing or I'm doing a describing. So whatever the case, it is accepted. So either you are using a description to identify the sets or to list the members, or listen the actual members. Like you can see on the screen, you can see the set A is equal to even numbers. That's, I'm using a description, so everybody who knows even numbers know the composition. Or if you look at the A equals to 2, 4, 6, then the etc. Whoever also sees this knows that I'm talking about the set of even numbers. Again, we can use another method called a set builder notation to describe a set. And when we talk about a set builder notation, it is basically um, a short exact description of the set. So for example, the set A that I described, I can write it in the set builder notation as A is such, X is such that X is an even number. So you can see the A here, then I'll open bracket and I said X is such that X is an even number, or I can use the ellipses, the dot and the slash means the same. So when you see the dots, that's the column, and the slash here, it is the same. It simply means X is such that X is an even number. So this is the third way I can describe a set, by using what we call the set builder notation. So this is what we call the set builder notation. Normally, you open a curly bracket, then you use a variable to represent the set. So we choose say X. Then so we are saying that X is such that X is an even number. So whatever is an even number is what we are making reference to in this set that A that we're talking about. Now, in the description of sets, we have what we call a universal set. And we normally use the letter U, this symbol or this symbol, to refer to the set of the set of all members under description. So when we're talking about the universal set, we are basically talking about the set of all elements under discussion. So for example, if I take the Ekropon Presbyterian Church of Ghana Assembly, for example, a congregation, for example, then that becomes the universal set. Then, for instance, if you want to talk about the fellowships in the church, then the fellowships becomes what we call the subset. So basically, when talking about universal set, the set of all elements or members under discussion. Then we have what we call the complement of a set. If I have a set A like this, then its complement is written as A prime. And when we talk about the complement of the set, it is basically the set of all elements that are in the universal set but not in set A. So if I have a set A and I have a universal set U, then the elements that are in the universal set U and that is not in the set A is what we call the complement of the set A. So basically, members that are in the universal set and not in the specified set. Also, in working with sets, we use normally what we call Venn diagrams to illustrate sets. And so Venn diagrams are used mostly to illustrate sets, especially in cases where we are doing 2 or 3 set problems. We normally use Venn diagrams to describe our sets. And if we have a set A and it has 5 members, we write it in this notation form. We write n into bracket A is equal to 5. The n into bracket A equals 5 means that the number of elements in the set A is 5. So when we want to write the number of elements or the number of members in the set, we use the small letter n and we put the set we are talking about, that's in this case A in bracket n, we say it's equal to the specified number. So for example, if I have a set A which contains the members 1, 2, 3, 4, 5, then n of A, which is the also called the cardinality or the number of elements in the set A, will be equal to 5. Okay, so now we're going to take a look at a 2-set problem, and I must quickly add that because of the constraint of time, the lesson has been a bit exam focused. So we're looking at the major areas that are covered in the examination. So some little basics have been taken out because of the constraint of time. So we want to look at the two-set problem. Normally, when we are given two-set problems, we normally use the Venn diagram to represent it. So as you can see on your screen, we have a set A, and this is the boundary of the set A. Then we have a set B. So so this circle is representing the set A, and this circle also representing the set A. And when we are using Venn diagram to represent circles, we normally put the sets in circles identified by the letter on top. Then we put the two circles or three circles, as the case may be, in a rectangle. And we normally put the universal set, which is U, outside. So what you are seeing here is a typical example of a Venn diagram that involves two sets, set A and set B. And we are going to take a look at the regions so that you will be familiar with how to work issues or problems that involves Venn diagrams. All right, so you can see on your screen two intersecting circles, set A and set B. And you can see four regions. We have the I, the II, and the III, and the IV. And the region I, as you can see on your screen, basically means that these elements in this section belongs to both set A and set B. Elements in the region I belongs to both set A and B. So we simply call it the section of set A and set B. Then the region II is where we put element that belongs to only the set A. So we, in other words, call it A, but not B. So if I have a question and the question is saying, for example, it's talking about two sets and a number is given, say, 2 is only belongs to only set A, or if, for instance, it's about reading of subjects like maybe mathematics and English, and the question is saying that maybe 5 people read only English, and we are using, say, A to represent the English, then that will come to this region, the II. Then the III, which is the third region, is the region for the elements or the members that belongs to only set B. And we also call it, in other words, B, but not A. Then the IV is where we have the complement that we talked about earlier. Normally, the sets, if you have, for example, a two-set problem, and we have members that do not belong to either set A or set B, then we put them in the region outside the circle. Anywhere, it can be on the right line, as you can see, or you can bring it to the left side. But basically, they're supposed to be outside the two intersecting circles. And finally, what we do is that if we have elements of the set that belongs to that do not belong to set A and set B, that's a complement of the set. What happens is that when you have a two-set problem, then when you solve them, one, all the elements in A, that's region I and II, must be equal to the number of elements in the set A. Then also all the elements in B, that's region I and region III, must be equal to the set B. Then when we are done to recheck also that region I plus region II plus region III plus region IV should be equal to the universal set. So when you solve any two-set problem, that's a way of checking whether you are right or you are wrong. And normally when we don't have any complement, that is, there is no element that does not belong to both A, that does not belong to either A or B, then this region IV will be off, so it will be left with I, and III. So it simply means that for the universal set U, it will be equal to the region I plus the region II plus the region II. But if the IV, then we have some complement, then the IV will be part of it. And if you have a case whereby we don't have the IV, then mathematically, we can say that the universal set could be equal to the number of A union B, that's putting all the elements of A and B together. And that will be equal to n of A plus n of B minus n of A intersection B. And let me explain quickly. You see, what we are saying is that if the region IV is not there, then mathematically the universal set, or basically the union, putting all the sets together as A union B, will be equal to this region, then plus this region. The reason why we are saying minus A intersection B is that if I do this region, that's the set A, then plus set B, you can see that the I has repeated twice. So you must take one I out. If not, then our number will not be equal to the universal set. And when we get to the first example, I think it will help us get it clearer. I hope you are with me. May I say that if anybody has any issue as we go on, the person could prompt me and revisit it so that it doesn't become a case whereby the whole time has elapsed and we don't know where exactly the person was lost. Okay, so let's take a look at a typical example. The question says that, and let me add that this was, if my memory serves me well, a past question I picked from the set of past questions that was sent to me. In a class of 40 students, 30 read mathematics, 20 read English. How many students read both mathematics and English? I hope you can all see the questions on the screen. Now, when you have a question like this, whether the question asks you to draw a Venn diagram or not, the first thing you need to do is to draw a Venn diagram. So you have to draw your Venn diagram. Then also, when you draw the Venn diagram, what you have to do is to determine variable to represent the set that has been talked about. So for example, you can see in our question, we've mentioned mathematics and we've mentioned English. So it is up to us to decide which variable to use to represent the set, because we can't be writing mathematics and English. It will be taking a lot of time and space. So normally we use a variable, like I said in the earlier description, to represent them. So in this case, I chose M, capital M, to represent mathematics and E to represent English. So as
I think, sir, your line is off. We can't hear you.
Yeah, I think Sir Benson has dropped. All right, so what is a universal set? When we say universal set, what comes into your mind? Anyone to give us an example of a universal set?
Yeah, he's back.
You don't want to answer my question, so he's back.
Oh, Papa, universal set is a set which contains all the elements of other sets.
That's fine. Thank you. All right.
All right. Smart.
I know. Don't mind me.
Hey. Hello.
Yes, you're welcome. Please continue.
All right. Sorry. Important comment. For WAEC marking, that's the West African Examination Council. Normally, when we are given a question like this, whether it's 2-set problem or 3-set problem, what the marking scheme normally gives marks to is the Venn diagram. For this, all that you can see here. In fact, I almost took them out, but I said I don't know how the marking scheme for our case would be. That's why I brought them. So let the number of students who read both mathematics and English be X, and let M be the students who read mathematics, let E be students who read English, let U be students in a class. All of them, they don't attract any marks as far as WAEC standard marking scheme is concerned. But we don't, since we might not know our case, it will be good to take some few minutes to do this. But essentially, what is important is the Venn diagram. So as you can see, I have n of m is equal to 30. It simply means that the number of students doing mathematics is 30, as the question gave us. And you can see n of e is equal to 20. So it simply means the number of students reading English is 20. Then you can see the n of u, that's the total number of students in the class outside here. Then you can see our x, that's representing both students who read English and mathematics in this region. Then what normally happens is that since this region, that's where you can see the 30 minus s, is supposed to be those who are doing only mathematics in this specific case, we have to take out the x. So this region now will be 30 minus x, so that when we are done, we know our x. Then when we take out the 30, then this will be only mathematics. Then the same is applicable here. So we do 20 minus x, so that when we are done calculating, then this will be only English. So normally that is how we approach it. When you are given, and also when we are given a specific value for the intersection, then we subtract it straight away from this. All right. So to solve, what we do is that since there is no that's element that do not belong to either of them, then it simply means that this region, that's those doing only mathematics plus those doing both mathematics and English, and those doing English and only should be equal to our total universal set. So as you can see, 30 minus x plus 20 minus s is supposed to be equal to 40. We are trying to find the number of students who do both English and math. So what we simply do that we add all the three regions here, the x region, that's the intersection, the mathematics, and the English region, and it should be equal to the universal set. Then what we do is that you can see that we have negative x here and x here. This x and this x will cancel out, so to be left with this negative x, and we add our 20 to our 30, and so we're going to have 50 minus s is equal to 40. Then like we do in all cases, this is the way you can approach it. Either like we say normally when we went to the primary school, I remember very well, the teacher will tell you that when x crosses the equal sign, it becomes positive, and it has negative crosses a negative equal sign, becomes positive, and positive crosses the equal sign, it becomes negative. But essentially, what is happening is that because this is an equation, we are trying to group like terms. So what we're going to do is that we, in this case, you want to send this value x, sorry, this to one side, the variable, that's 50 and 40 to one side, and x will be on the other side. So if you like to go the crook way, this x will cross the equal sign to the other side to be positive, then the 40 will cross the equal sign to this here to be negative. But essentially, we're going to subtract 50 from each side of the we're going to subtract 40 because we want to save the 40 to this side and we save the x to this side. So what we're going to do is that we subtract 40 from both sides of the equation. So 40, so this side will be 50 minus 40, and to bring us to the 10. Then this side will be 40 minus 40, so that will go to a 0. Then let me see whether I could get a pen to illustrate this. So what I'm trying to say is that this will be equal to, we have so 50 minus 40, is that okay? Then minus our x will be equal to 40, okay, minus 40. So what I've done in the first case is try to eliminate the variable, that's the 40 first. Then this will bring me to, this will be 10 minus x, and it will be equal to 0. 40 minus 40 will be 0. Now I'll now try to make sure that I save the x. So what I will simply do is that I will add x here, then I will add x here. Is it okay? So now this x and this x will go to 0, and here will be x. But by default, we normally write our variable on the left side and the number on the right side. So that's why you can see in the final answer here, we have x on the left side and 10 on the right side. So basically, those who are doing both x and y now will be 10. So we just conclude that therefore students who read both mathematics and English will be equal to 10. I would like to pause here, since this is our first example, to ask if there is any issue, or if everybody's okay, then we carry on. Hello. Hello.
Yes.
Please, are you there? Please, is the example
clear,
okay? Or it's clear?
It's clear.
So as you carry on. Okay.
No.
If it,
Pastor,
Yes.
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 hello.
Hello, yeah.
Yes.
Pastor, yeah. Pastor, if you can go over it again for us.
Thank you, dear. Looking at the question, we've been told that in a class we have 40 students in that class, and 30 read mathematics and 20 read English. And the question has asked us to find how many students read both mathematics and English.
Yeah.
Please, I hope you got my explanation to the bit about the writing the preamble. That's the this one, let x all those stuff.
Yeah.
Okay. Like I said, I don't know what the marking scheme will stipulate. So if they don't award marks, then you can simply focus on the Venn diagram. But if they award marks, you need to take some few minutes to do this. But simply, you will let a variable represent the first set that you've been given. Then another variable represent the second set. Normally, we use U to represent, or the echelon sign to represent the universal set. So by default, we normally write U. So with that, that means we have to draw two intersecting circles. Since the question is saying both, it means that we have to draw two intersecting circles. So we will first draw this circle, then we draw the other circle. And you are free to label which one to be your M and your E. But since the M came first, we decided to make the first circle label this as M and the second circle as E. And we've written N of, there are two ways actually to write this. Either I simply write M, then into bracket, you see it in the second example, M into bracket 30, or I write N of M is equal to 30. And the same thing applies here. Either I simply write E into bracket 20, and or I write N of E is equal to 20. But whatever approach you choose must be the same for all of them. So for example, you see N of M equals 30 here, N of E equals 20, and N of E equals 40. Then, since we are not giving those who do read both English and mathematics, we let X represent that. So we put X here. Then when it comes to this region, in the final analysis, this region is supposed to represent those who are reading only mathematics. But you know, the mathematics for all the entire circle here. So for us to get only mathematics, we must come and take out those who are doing both mathematics. Good. Take out X from this, and the same applies here, so that we get only English. So for example, the question could have gone further to ask you for those who do read only mathematics and who read only English. Okay. So with that, since the question didn't tell us that none of the students read any of them, then it simply means that when we add all these three regions, this region plus this region plus this region is equal to the universal set, that's the number of elements or the number of students in the class. So that's what you've done. So you start with 30 minus x, then plus this region plus x, then plus this region 20 plus x should be equal to 40. Are you with me there? Hello there.
Yes,
Okay,
sir.
I guess you can hear me. So with that done, what we do is that when you look at this, we have negative x and positive x. Is it okay? So this x and this x will cancel out. Then we'll be left with this x, it's negative. Then we add this 20 to this 30. That's how come we are having 50 minus x equals
X.
40. Is it okay? And
Mm.
if you would like us to go our old way, then what we'll simply do is that this 40 will cross the equal sign and to become negative, and this x will cross the equal sign and become positive. Like I told you when we were growing up, that's what our teachers used to tell us. I'm sure they were thinking of a simple way to let us understand the whole bit. But what basically happened, I don't know whether this illustration that I've done is still on the screen. You can see on the screen there. The one I
Yeah.
just wrote, yeah. So what simply, since it's an equation, what we normally do is that what you do to the left hand of the equation, you do to the right hand. So what I decided to do in this case was to take out the 40 first. So I'll subtract 40 from both sides. So you can see that you have 50 minus 40 minus x equal to 40 minus 40. So this will go to 0. Then this will be now 10. 50 minus 40 will give us 10 minus x.
10.
Then now I want to take out the x. We have 10 minus x equals 0. So I add x here and I add x in their equation. So negative x plus x will also go to 0. And 0 plus x will be x. So it will now be 10 is equal to x. But like I told you, by default, we normally write the variables on the left side of the equation. That's why you can see that we have got the x to the left and the 10 to the right. So this is just a conclusion, but there are some marking schemes when you don't conclude, they deduct marks. I've seen in Y cases whereby so when students don't conclude, if this is 5 marks, student will get 4 out of 5. So it will not take much to just conclude that. Therefore, 10 students read both mathematics and English. Are we good now?
Yeah.
Okay, so let's look at our second example. This is also from your past questions, I remember, if I'm researching what to say. This also says in a village with 150 farmers, 90 farmers grow cassava, 80 farmers grow plantain, and 40 farmers grow both cassava and plantain. And the question is, how many farmers grow cassava only, B, plantain only, then C, neither cassava nor plantain? Take a minute to read the question again if you can see on your screen so that it will stick and
Papa, so when you see this, it means you are to draw a Venn diagram to illustrate it by yourself.
yes, even if they don't ask you to do that, because normally, like I've told you, the work experience that I've had, and I've been marking YX since 2012 till date. Whether they ask you to draw or not, they give marks for the Venn diagram.
Wow.
Yes, yeah. The idea is that the Venn diagram that helps you to solve it easily, because if not, you can make mistakes whilst you are trying to imagine it in your mind. Is that okay? Yeah, so whether you are asked to draw or not, please draw. Is that Kisley who is still driving?
Yes.
Oh, wow. I'm in love with you, trust me. Anyway, all right, so
That's my
please.
job.
So this is the Venn diagram. So like we are saying, normally when we are also giving, we try to, if they don't coincide, we try to choose the first variable of the set we are given to represent the set. So as you can see, I've chosen C here and I've chosen P here. But if they coincide, you can use any other variable, but it's up to you. That's why if you want to define, you will say let X or whatever be whatever variable. So if I decide not to let C be cassava, I can choose any variable and the marking scheme must accept it. So long as you have defined your variable for your cassava and your plantain and the universal set, it must be accepted. But by default, we are choosing C to represent our cassava, then P to represent our plantain, then the U represent universal set. So as you can see, the question told us that, so this will be the circle for the cassava, and this will be the circle for the plantain. And we were told that 40 farmers wrote both cassava and plantain, so we put it in this region. This region is for those who belong to both. Now in this case,
Cassava and plantain.
Thank you. Then here we were told that 90 were for cassava farmers. So we have to subtract this 40 from the 90. The idea is to help us get our only. Is that okay?
Cassava. Yeah. Okay.
So that's why you can see 90 minus 40 in the this section. Then the same applies here. You can see 80 minus 40 because 80 is doing plantain, but we want here to get only those who are doing growing only plantain. So we have to subtract this 40, which belongs to both the plantain and the cassava, from the 80. So as you can see, that's why I've intentionally put the 50 in the bracket here and the 40 in the bracket, and our universal set is there. So you saw in the first example, let me quickly go back. You saw that I use N of M here, and I use N of E and N of U here. But here I'm using C, is that okay, into bracket 90, P into bracket 80, and U into bracket 150. I'll tell this another way you can also present it. So it's up to you. Is okay, either you do it this way or the N of. So if you wanted the other way, then this would have been N of C is equal to 90, N of P is equal to 80, and now N of U is equal to 150. Okay. So now our question, the first question was for cassava only. So this, since we have said it, we just pick it out and write cassava only is equal to 90 minus 40, and this is equal to 50. When you take out 40 from 90, we're going to get 50. Then also for plantain only, we are going to do 80 minus 40. Then the question is asking also, and that brings us to 40 as you see. Then the question is also asking us that you find those who do neither cassava nor plantain. Normally, when there is a neither like that, what you do is that it means that this region plus this region plus this region should not be equal to, should be less than the universal set. If it's equal, then it means that none does neither. If not, then it should be less than for us to get our value. So as you can see, neither cassava and plantain on your skin, we are doing 150 minus this 50 plus 40 plus 40. That's adding all the three regions. And 50 plus this will give us 190, then plus 40 will give us
130.
130.
130.
So, yes, so this is 130. Then 150 minus 130 will give us
20.
Yeah. So that's how come you are seeing that. So this sum is giving us 130. So in the end, we are doing 150 minus 130, and we're going to get 20 farmers.
Oh, I'm getting it.
All right. So this will bring us to the end of this question too.
Baba, so I wish they bring the same question like this, because this one I've understood it.
In fact, these two questions are fun. So if you are lucky, they repeat, then you just produce the answers for them, then you will carry on.
Yeah.
Actually, when I went through, I had only 2 examples of the 2 set problems, so I picked them. Okay, so
Wishes are horses.
don't worry, pray, and in everything, prayer is involved. No, the person selects, so you just have to pray. And so let's take a look at this example too. Can you all see the screen?
Yeah.
Yes. It says in a certain village, 45% are public servants, 70% are and 70% are farmers. Each person is in at least one of the jobs. Find the number of people who are in both jobs. And let me draw attention that anytime that a question brings this, each person is in actually, then it means there is no neither. Please, are you with me?
Okay.
It means that the region 4 will be 0. That means that this region plus this region plus this region should be equal to the universal set. Is that okay?
Okay.
All right. So, and normally in such a question that they are saying percentage, they will not tell you that the total percentage is 100. You see, they didn't see any 100% inside. But we know that total percentage is supposed to be 100 because 100% is the standard measure.
Okay.
Is that okay? So in such a question, they will not tell the universal set, but you should know that it's supposed to be 100. So you can see that we've chosen P to represent our public servant. That's why you can see a P here. Then we have chosen F to represent farmers. And please, these must be capital letters, please. They must be capital letters. We use capital letters to represent sets. So you can see a capital P and a capital F here, then a U here. So we were given 45% for the public servants. So you can see 45% in brackets and 70% and in also bracket for the farmers. So we will let our X be the number of people in both jobs. So we put the X here. Is that okay? Then it means that this side, the plantain side, will be 45 minus X. Is that okay? Then the other side, the farmer side, to be 70 minus X. Then when we set this Venn diagram, then we are good to go. Then what we simply do is that we're looking for a number of people in both jobs. What do? We know that this region plus this region plus this region is supposed to be equal to the universal set. So it's simply 45 minus X plus 70 minus X is equal to 100. We are simply adding region 1 plus region 2 plus region 3. Is that okay? And putting it to the universal set, that's 100%. So in our first case, this X is positive, negative, this X is positive. So this X and this S will cancel out since they are of the same value. And so we left with this X. So we will add this 45 to 70, and that will bring us to 115. I hope I'm right. My calculator is false, so
yes, it's 115.
Yeah, so 115 minus S is equal to 100. And like it happened in the first case, we will subtract 100 from both sides, and we will add X to both sides. So if you like, the 100 will cross the equal sign to this side to be negative, then the X will cross the equal sign to this side to be positive. So essentially, we're going to have 115 minus 100, like we did in the first case, which will be equal to X.
Papa, so you just said if I like, the 100 will cross the equal sign to become negative. Yes. So what if I don't like? Because
like I said, if you heard me in the beginning, I said that that is how we were taught in the primary school. But essentially, what happens is that, like I was telling you, when we look at this equation, now we want the variable X to be at one side and the number, that's 115 and 100 to be at the other side of the equation. So since it's an equation, what we do is that we first eliminate, we first group one of the variables. So we want to group the 100 and the 115. Is that okay? So we want the 100 to shift. You could have shifted the 115, but we have to be careful when we're dealing with negatives. Is that okay? So that's why I want to move the 100. So I'll subtract 100 from both sides. So when I subtract 100 from both sides, then this will be In the first place, it will be 1. Let me write it down here. Okay, let me bring it here. It will be 1, 1, 5 minus 100. Don't worry. Then minus x. Is that okay? It's equal to 100. You see, it's an equation. So whatever I do to the left hand side, I must do the same to the right hand side. Minus 100. Is that okay?
Okay.
And I've been saying if you like, because normally for this side, why you could not pay attention so much. The next thing is getting the, because they know that you can simply subtract and do that. So, you know, this and that will go. This and that will go away. They will cancel out. And this will be left what? 115 minus 100 will be left with 15, right? So it will be 15 minus x. Is that okay? It's equal to 0. Is that okay? Let me do my x well. Now, so I've managed to now take out my 100. Now it's left with the x. So I do now 15 minus x plus x. Is that okay? It's equal to 0 plus, it's an equation, so I'm adding x to both sides. Is that okay? Yes, if you want to do a lot of explanation, then in this case would have been subtracting 100 from both sides, and this case would be adding x to both sides. Is that okay? So now this and also this will cancel out. So it's now be 15 here. Let me curve it a little. 15 then is equal to x. All right, so like I said, by default, we write the x in the left side of the equation. So by convention, as we say. So now our x will finally be equal to 15. Is that okay? All right, so that's how come you see that x is equal to 15 on your screen right now. So since it's that, you also conclude that, therefore, don't forget that the question was given in percentage. So essentially this 15 is 15%. Is okay? So we therefore conclude that 15% of the people are in both jobs. 50% of the people are in both jobs. I hope you are good. Hello.
Yeah.
So, Papa, let me ask this question. You see, you use X to represent each person is in at least one of the jobs.
Yes, that represents the number of people in both jobs.
The
Yeah,
universal.
You can choose any variable at all you like.
Okay, that's what I mean.
Yes.
All right.
But you know, we are more familiar with the X and Y's. So the X and Y's have been suffering under our hands. But you can use any variable essentially. That's why you define it. You see, that's why you have on top here, let X be the number of people in both jobs. And at times our questions also can give you specifically to use the X. And when the question gives like that, then you have to use it like that. Can we carry on?
Hello. Papa, I wish you don't carry on, but you only use this and go over again because if you bring another one, it will be a whole lot of, you know.
I also had a female voice at the background. I don't know if there's a question too. Yes, please, can I hear you?
Papa, please, so instead of is it lose marks if you don't add the X to both sides as you are working it?
No, you can actually jump to this place. Is it okay?
So you can go straight away.
Exactly like our presentation. You see, you look at my presentation itself. Is it okay? you can see that okay, let's see. I wanted to clear this. Let me see. Excuse me, I want to quickly clear so that all right. So please, you can see the left side of this. You see, this is how I presented, and this is accepted. Please, have you seen this presentation? Yeah, this is accepted by any standard marking scheme. But I was just doing it just for illustration, for further explanation. So if you can do this, then please, you are good to go because it is accepted.
Okay.
Yeah.
Okay, Papa. So it means I can go ahead and just cancel the 2x after the 45 and have 45 minus 70.
45 plus 70, please.
Plus
This is
70.
Plus 70.
Yes.
Oh, okay.
Then you get 115.
Minus x. Okay. Okay. So then the 100 will jump to the 115 side.
Yes, please.
Then go to the other side.
Yes, please.
Okay, Papa.
So jumping, and I had you know. Yeah.
Okay. All right. So, like I was saying, that please remember because the question was given in percentages. This 15 is 15%. So when you're calculating, it should be 15% of the people are in both jobs.
Okay.
Can we make progress now?
No.
So you
Yes,
please immediately I finish this lesson, I will share the slide with you. So you please go back and go over. And like I've told you, if it's not clear, you can let me. You can private chat me privately on WhatsApp, and we can do on one-on-one. We can even do a WhatsApp talk. So don't worry. Whatever is not clear, let me know. Okay, so this is for you to try your hands on, but not now because of time constraint. Is that okay?
Okay.
Okay.
A slide with you, try your hands on it, and I try to provide the answer so that you'll be sure whether you are right or wrong. If it's not clear, you get back to me privately, and we'll look at that. So you try your hands on these two questions for me. This also I tried to bring the answer for the Venn diagram. I took it up because I tried that by now. You can draw the Venn diagram. Okay, with that done, then we come to where it's a little challenging at times. That's the 3 set problem, but it's not even so difficult. We just have to really understand. Then we will. Okay, so please look at that. I have 3 slides that is trying to explain all the regions because all couldn't go on one slide. But I will stay on this very slide because when you get it, then it covers all of them. Is that okay? Essentially, why we normally do the Venn diagram is that when you are able to put wherever anybody belongs appropriately, then you can easily solve your question. You can answer whatever question that it comes under 3 set rule. I think the only time that the only addition they will do is they will add a probability question. At times they will add probability question. So one of your examples that I put was a probability question, but because we have not gotten there, I took it out for now. So you can see that we have 3 intersecting circles: circle A, circle B, circle C, and we have the universal set sitting in. Like I've told you always, you put the circles in a rectangle and you put the universal set outside. Good. And in the same way, this region I is for those who are doing, or in this case, those who belong to set A, B, and C at the same time. Is that okay? The I belongs to all the 3. Then I want to talk about the II. Is that okay? It is for those who are belonging to A and B.
A and B.
Only. But please let me draw attention quickly to this. When the question says that maybe 50 belong to A and B, it means it's for all this region. Is that okay? Then it means I must subtract this from the value to get the only B. But if the question says only B, then I'll put that value here without subtracting. Please, is that clear? Please, is that clear? Because that can trick students and can get students off track. Let me say it again. I'm only considering region I and II for now. Please, are you with me? Good. For the I, it is for those who belong to A, B, and C. Then the II belongs to A and B only. Is that okay?
Yeah.
So, but in a question can say A and B only, or they'll just say A and B. When they just say A and B, that means you have to subtract this one from the A and B before you get the A and B only.
A and B. Okay.
You know, when we come to the example, I will try to throw more light on that so that it becomes clear. So region II is for those who belong to A and B only. Then the III is A and C only. Then the IV is B and C only.
B and C.
Only. Then V is for A only.
A
only.
Good. Then VI is for B only.
B only.
VII is for C only. Then VII, you can see it's outside. He doesn't belong to any of them. So when you don't, for instance, if you are talking about maybe some toffees and you don't like any of them, then you will be outside here. So if we have, and for the three set problem, normally what you must check is that when you add all in the circle of A, they must be equal to the value of A. When you add all in the circle of B, they must be equal to the value of B. When you add all in the circle of C, they must be equal to the value of C. Is that okay?
Yeah.
Then if it's one that does not belong to all of them, you put them here. Then for the universal, it will be this region plus 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 this and that. Then if there is one that does not belong to any, plus this to be equal to the universal. But if in case this is not there, then it will be this plus this plus this plus that plus this plus this plus that. And you must be careful not to repeat any of them. If not, you'll get your question wrong. So another way is that it is simply all of A plus VII plus IV plus B. That will also be the same to be equal to U. Is that okay? So this is basically the description of all the regions, and I've tried to write it down under them. Like I told you, 3 slides have been used to explain this. So when you later go through, I'm sure you'll be good. And our examples will help us. So let's carry on to our examples because that will help us to practicalize whatever we are learning. All right. This is also your past question.
Hey.
Yes, we had to. Excuse me, let me sip some water.
Okay. I feel ready. I'm say so for dinner next year. Na my top way see Papa,
you can do it. And like I told you, I'll be available for every presentation I do, and I'll be available for further clarification if you like. But please be positive. Be positive, please.
Well, Papa Mati.
Be positive. Be positive, please. All right. Good. So looking at this, for example, there are 174 members in the congregation at Akosombo. Of these, 86 belong to the youth fellowship, 84 belong to the men's fellowship, and 94 are members of the women fellowship. 30 belong to the youth fellowship and women fellowship, 34 are in women fellowship and the men's fellowship, and 40 belong to the youth fellowship and men fellowship. Each member belongs to at least one of these 3 fellowship groups. Assuming that X stands for the members who belong to all the 3 groups mentioned, represent the given information in a Venn diagram and find the value of X. So you can see that in this question, they have defined the X for us. So it means in this question, you cannot choose your own variable. Yeah, so You can see that when I was trying to also do the definition, I said let you be members in the congregation. Then we chose Y for the youth. So Y be members of the youth fellowship. Then M for the men. So M be the members of the men fellowship. Then W be the members for the women fellowship. You see that I didn't mention those who belong to all the three because it has already been defined in the question. Is that okay? Now, let me take my time to explain to you. You can all see the Venn diagram. You see Y is sitting here. Y is representing the youth fellowship. M is representing the men fellowship. W is representing the women fellowship. And U is sitting outside. So you can see U into bracket 174. That was the number that was given in the question. Then you can see Y into bracket 86. That was what was given. M into bracket 84, that's what was given for the men, and W into bracket 94, that's what was given in the women fellowship. Then we were told to use S for those who belong to all the three. And as you can see, the S is here because here is the region for all those who belong to all the three. Is that okay?
Mm-hmm.
Then we were told in the question that 42. Let me start with the first one first. Let me take this screen off so that I can see the question clearly. Good. We're told that 30, you can see my point, 30 belong to the youth fellowship and the women fellowship. And this is my youth fellowship, this is my women fellowship. So the 30 must come here. Are you with me? Hello?
Yeah.
Can you see my screen?
Yes.
Yeah.
So the 30 must be here. But since it didn't say 30 only, then it means that we must subtract our X from the 30. Are you with me? If the question has said 30 only, then I would have written 30 without subtracting the X from it. But since the question didn't say 30 only, then this would be 30 minus X. Then the next was 34 in both women fellowship and men fellowship. What is the women? This is the circle for the women. This is for the men. So this would be the region for both women fellowship and men fellowship. But since also it didn't say only, I will do 34 minus X. I'll subtract my X because in the final analysis, I want to get this to be men and women fellowship only. Is that okay? So I'll take this region out, like I explained earlier. Then finally, we were told that 42 belong to both youth and men fellowship. So this is the circle for the youth, and this is for the men. So this will be their intersection region. Is that okay? So that also they didn't say this to be 42 minus X. Is that okay? So here you can see a variable A, you can see a variable B, you can see a variable C on your screen. We were not giving those for youth only, those for men fellowship only, and those for women fellowship only. So we just chose variable to represent them. Is that okay? That's why you are seeing A, B, and C on your screen. Simply because we are not giving values for them. Is that okay?
Yes.
Yeah.
Now let's carry on. So our this thing is sitting there. So now what do we do? Since the question has asked us to find all, since we don't know the only for the youth, the men fellowship and the women fellowship, we have to take them one by one so that we get our values for our A, our B, and our C. Is that okay? So I will come to the youth, and this is the region for the youth. So the youth will be this region plus this region plus this region plus this region to be equal to 86. Is that okay? Good. So you can see that youth is equal to A plus this one, that's 30 minus X, plus this one X, then plus this 42 minus X. Then it should be equal to what? 86. Is that okay? And like in the first case, we have 30 and 42 here. So we add the two values. 30 plus 42 give us a 72. That's why you can see 72 here. Then this x and this x will cancel out because this is negative, this is positive. So we'll be left with this x. That's why it implies that I have a plus 72 minus s is equal to 86. Are you okay? Then since I am looking for the a, is it okay? Let me quickly change to a pen and see whether I could do a little illustration. Since I'm looking for the a, I will simply now take this to this side and take this to this side. How do I do it? I subtract 72 from both sides and I add x to both sides. Is that okay? But basically, for your interest, like we were taught when we were growing up, simply this is not the standard mathematics. That's why I say when you go the old way, simply when the 72 positive is equals to be negative 72, then when this is to be positive x. But essentially, we are subtracting 72 from both sides and adding x to both sides. Are you okay?
Yes.
So this would have been a, then plus 70. Let me do my 72. 72 minus 72, then minus x. Is that okay? If we decide to do it one by one, then it will be equal to 86 minus 72. Is that okay?
42.
Let me try and write it to work. Okay, so 8 minus 70, 86 minus 72. So now I'll be left with what? A minus x is equal to, I want to do a subtraction, you know, when you arrange them well, this will be 86. So 2 from 6 will be 4, and 7 from 8 will be that. So essentially 86 minus 72 will give us a 14. Is that okay?
Yes.
Now, because I'm interested in the x, I want the x to be the subject of the equation. We call it making it the subject. So I'll now, you see this negative x, so I'll add x to both sides so that this s will be gone. So now a minus x plus x. Is that okay?
Yes.
Equals 14. I should have written my one. 14 plus x. Okay, so finally, we'll get what we have here. That's why you are finally seeing that we have a is equal to, therefore a is equal to 14 plus x. Is that okay? So let me write it here. We need it. So 14. Now, in the exam, you can use pencil plus x because it's not part of your Venn diagram. But then the same will apply to the main fellowship. So if you got out of the use the same analogy. So when you take the main fellowship, it also means that this region B plus this region plus this region plus this region should be equal to 84. So that's why you can see B plus 34 minus x plus 42 minus x is equal to 84. And when I add my two values, that's 34 and 42, I'll get 76. So So that's why you can see that. And this x and this x will cancel. And it will be left with this as, please, there is an omission of x here. I'll have to edit it. So it's supposed to be minus x here. So there's minus x. I'll edit it before I put it on the page. Is that okay? Minus x is equal to 80. So like we went through, when you go through this again, then we're going to get, therefore, b is equal to 8 plus x. We're going to subtract 76 from both sides. So 76 from 84 will give us 8. Then since this is negative x, we add x to both sides, and that will give us that. And like I was prompted earlier by the lady that I don't know the name, when you do it like this, it is still accepted because they know that this is what you've gone through to get this value. Is that okay? Good.
Okay.
Then the same will apply to the human. So we take it set by set. Is that okay? So we'll go to the human fellowship too. So we'll pick this region C. Then this region, let me quickly add this one because of, so this will be 8 plus x. Is that okay? Then we come to that's the human fellowship. So that one too is this region plus this region plus this region plus region should be equal to 94. So as you can see, we have said that C plus 30 minus x plus 34 minus x is equal to 94. What happened? This also, there's an omission of x here.
Yeah.
So I'll edit it before I put it on the page for you. Okay, so that will also be, we have 30 plus 34. That will give us
64.
LA.
Hi.
LA. Yeah, sorry about that. So
Yes, sir.
C
Okay, go ahead.
and the same way we subtract 64 from both sides. So we have 94 minus 64. That will give us a 30. Then we add x to both sides. So we have, this will go to 0. Then we have 30 plus x. That's why we are seeing 30 plus x here. So this also I'll write 30 plus x. Is it okay? And now that I've done this, then what it simply means is that for me to get my value x, I'll add this region to this region to this region to this region. Then I'll come here, here, and here, and also be equal to the universal set. Is that okay? So you can see that I wrote that's 14 plus 6. That's the first one. Then I come here. So I move in this order. Is that okay? This order, kind of a serpentine order. Is that okay? Because if you don't do it well, you will repeat some. So it will be this region 14 plus x, then this region 42.
But kind of what kind of what order?
I said serpentine. Looking at like an S, so I just said serpentine. Don't worry.
Serpentine.
So just terminology that I find here. Yeah, but essentially, you start from a region, you note it, then you go from region because each region must appear only once. Yeah. It's okay. That's what it is. So you can put your hand on it, the pencil on it, whatever. Like, and you're crossing it one by one so that you make sure no one is duplicated. Because when it's duplicated, it will affect your results. So you can see that it's 14 plus x plus 30 minus x plus 42 minus x plus 8 plus x plus 30 minus x plus 30 plus x is supposed to be equal to 174. Okay, so when you've added all the regions together, then you cancel one that needs to be cancelled. So you can see that we have positive x here a negative x. So this x and this x will cancel. Then another positive x, another positive negative x. So this x and this x will also cancel out. Then you have a positive x, another negative x. So this x and this x will cancel. So you can see that we are left with only one x. Is that okay? So now we have our value. So we're going to add our 14 to our 30, to our 40, to our 8, to our 34, and 30. Please, can you quickly do that addition for me? For us to be double sure. If anybody is having a calculator, they can simply add, because this one, I'm sure they will allow you to use calculator. So you need not to try to do this mentally. Is anybody doing the addition for us?
Yeah, it's
158.
Good. So it will bring us 158. So that's why you can see x plus 158 is equal to 174. So now since it's only this, I simply subtract 158 from both sides. So this side will be minus 158 minus 158. Then this side too will be minus 158. Is that okay? So that's why we are getting x equal to 174 minus 150, and this is giving us 60. So it means that 60 members belong to all the three groups. We found our x now. Now let me erase and draw attention to something quickly, so that it will be a check for you to know whether you are right or you are wrong. So let me pick my eraser. Let me clear something and I'll explain something. I just want this guy off. I want this guy out. Good. So please, can you all see the Venn diagram now?
yes.
Good. You see this value, our x is now what? 16. So let's put the 16 here. Is that okay? Then, so we subtract 16 from 30. What are we going to get? We're going to get 14,
12.
right? 14. So this will be 1, 4. Is that okay? Here we are adding, so this will be what? 4, 6. We are adding 60, 30, so 46. Is that okay? Here, 34 minus 16. What are we going to get? Second?
22.
Okay. So 34 minus 16 is 22. 34 minus 16 is 22.
18.
18.
Thank you. 18. Good. So it's 18. Then here we're adding, so it's about 24, right?
Yeah, 24.
Yeah, 24. Then I think we are left with this region. So 42 minus, okay, this is also there. 42 minus 16. 42 minus 16 will bring us what?
4.
26,
Again.
right?
26. Thank you.
26.
26. Mm-hmm.
26. Then here, 16 plus
30.
14 will bring us 40. Thank you. 30, no.
30.
30,
That will be
yeah.
30.
Yeah. 30. Excuse me, let me quickly erase so that I can write it properly at the right place. Okay, yeah, our time is right now, but this is very important to get this, and we are good. The rest, okay. Why I've done this is that this is a check for us. It means that all the values that are added in this youth region should be equal to 86. Is that okay? Then all the values in the M region should be equal to 84. Then all the values in the W region, that's the women's fellowship, should be equal to 94. Then when I finish, when I add all these regions, I should get 174. And that's a way for you to check that you are right. And that one, even without seeing the marking scheme or knowing the answers, you know that you are right. So let's do one for the youth. So for the youth, for instance, it means that 30 plus 30 plus 26 is okay, plus 16. What is left? Plus 14. Should be equal to 86, and I think it is. If not, it means we are wrong.
Yes, 86.
Yes, if it's not, then it means you are wrong somewhere. You have to reverse it. So that's a way for you to check that you are correct. But of course, if you're under pressure, you are sure you are right, you can just ignore it. But this one is not part of the marking scheme anyway. And you can see that when we do same, this will give us 84. This will give us 94. And when we add all these values together, it will bring us to 174. You can check when we are done because of time. Is it clear?
Yes.
Yeah.
Okay, thank you. But people of God, I tried. You can see there is no solution for this question. I tried solving it, but there is a little challenge with the question. So I don't know. Maybe whoever said the question must need to revisit the question. You see, I've highlighted the one here. You see, the one that I highlighted, they say one claims to have visited both Catholic and the Protestant church. But okay, let me start. You see, the question says in every Christian at Nyame Kurom has visited either the Catholic, Protestant, or other churches. 10 have visited the Catholic Church, 8 the Protestant, and 17 other churches. One claims to have visited both the Catholic and the Protestant, and that's the first point I have my challenge with the question. You see, the question didn't say one only. So it means essentially I must do 1 minus x here. Is that okay? But when I do 1 minus whatever value I'm getting here, it will either bring this to 0 or it will be negative. Are you with me? Hello?
Yes.
Yes, Papa, we are with you.
If we get 1 for and bring it to 0, it means that this claim is also not correct. So I was wondering whether it's supposed to be only. And if it's supposed to be only, then the question that was also coming to my mind is that then what about this 6? So the 6 also only, and is the 3 also only? So I have left it like that. I don't know. I don't know whether Reverend is on the line. Reverend Dr. Awuku. Rev, are you there? But to clear your mind, it has happened in WAEC before. I think one of the latest mathematics questions, I think, is it 2014 thereabout? There was a mistake in the question. They didn't realize until the question has been administered. So what they did was that they marked up to a point, and from where the mistake was, they awarded the 4 marks. Oh, and I'm sure if that is the case for this, it will also happen, because if we work this, then when we get this will become negative. And then when I worked, I tried to assume this to be not only. And when I worked, I had a value. I think I had 6 or so. And when you subtract 6, you get negative. There's no way you can say negative 5 or 4, and it will even change the claim here. And I don't know whether we assume these are onlys. So I've left this for now. I don't know. I just decided to leave it. Hello.
Hello.
Yeah, this was the second question that was in your marking, your past question, but because of the challenge I have with the question, I decided to leave it because it will be difficult to have a solution to this unless we get the clarification for what I'm raising. Of course,
All right, thank you.
mathematically we can solve, we can get values, but that's what really happened. All right, so because of that, I took another example, and I'm sure this will be our last example because our time is almost up. All right, so as you can see on your screen, the question says that there are 30 students in the class. 20 of them play football, 16 play hockey, and 16 play volley. 9 play all 3 games, 15 play football and volleyball, 11 play football and hockey, and 10 play hockey and volleyball. A, illustrate the information on the Venn diagram. Be using your Venn diagram, find the number of students who play at least 2 games. And please, when the question is like this, you have to pay attention. The question said at least 2 games, and it's very important. A lecturer used to tell us that answering the question is part of the exam. Is that okay? Because when you don't get this one clear, it will let you get your answer wrong. But let's focus on it. So, like we did in the first case, we have to choose our variable to represent ourselves. So, since we have football, hockey, and volleyball, we decided to choose the first variable. So, we use capital F for the football, capital H for the hockey, and V for the volley. So, we have their various values in the bracket, as you can see. We're given 9 to play all. So you see the 9 is sitting here. Is that okay? Then they said, let me start with the first one. 15 play football and volleyball. So you can see that I've done 15 minus 9 because they didn't say only. Is it okay? When the question says only, then I would have written only 15. But since they didn't say only, then we must do 15 minus 9. Then here too, they said 11 play volleyball. 11 play football and hockey. This is football and hockey. So our place is that one also. I'm doing 11 minus 9 because they didn't say only. Then finally 10 play hockey and volleyball. This is hockey, this is volleyball. We're also doing 10 minus 9. Since it didn't say only, we do that. We were not giving for football only. We're not giving hockey only. We're not giving volleyball. So we are still using the variable. I still chose A, B, and C to represent them. Is that okay? So I set it up like I did in the first case. I start with my football. So I start with this circle first. So it means, when I do this will give me 2, and this will be what 6. Is that okay? So it means that A plus 2 plus 9 plus 6 will be equal to 20. And this will give us what 11 plus this, that's 17. So it's going to have our time is up plus 17 is equal to 20. Is that okay? Then we subtract 17 from both sides, then we get finally 8 equal to 3. Is that okay? Then we come to the hockey. The hockey to the same thing. We will pick this region. So it will be this will also be 1. So it will be B plus 2 plus 9 plus 1 to be equal to 16, which is the sum. So that one also we are getting 12 for the values. So B plus 12. So 12 minus 16, you subtract 12 from both sides, and that will also give us 4. Then we come to the volleyball to the same apply. So it's going to be the C plus this 6 plus 9 plus 1. And this will also give us 16. So 16 minus 16 will be 0. So it means that this will be 0.
All right. Our time is up.
Yeah, Papa, I'm wrapping up with this one and I'll be gone. So please pay attention. The question said that at least 2 games. Is it okay? So there are at least 2 games. It means 2 or more. It means that it will be this region plus this region plus this region. This is for 2, but what says at least you must add this one. The 3 set. Please, are you with me? That's why you can see at least 2 games. We have 2 plus 6 plus 1 plus 9, and it's equal to 18. So that's all. So I'm actually done at this point. So you are supposed to try your hands on this one for me, and I've also tried to provide the answers for that. So here na yezi I can see na bekoneri. Yankopɔn no nka yɛn nyinaa ho. Amen.
Amen. Thank you very much.
All right. So thank you, Baba.